Hey, make sure you have your 2.3 Unit 2 notes out titled Evaluate and Simplifying Fractions. Our essential question, kind of the overall question that we want to be able to answer at the end of this lesson is, how do you use the order of operations to calculate equivalent fractions? So we are bringing back order of operations, and that's from Unit 1. We're also going to bring back the things that we reviewed in Lesson 2.2 and Lesson 2.1. So just a quick heads up, there are 4 spots for examples on the front of your notes. We're only going to put 2 examples on the front of your notes. We're going to put 3 examples on the back of your notes just to give some extra space. So here we go. Our job is to evaluate. Do you see where I am in your notes? Evaluate each fraction for the given variable amounts. Express each answer in simplest form. Okay, I want you to be thinking, why do we simplify so much in math? What is the purpose of doing that? Kind of be thinking about that as we go through this lesson. So here is problem 1. Our fraction is a over b, and we need to evaluate, write this down with me, when a equals -4 and b equals -6. So we have 2 negative integers that we're going to be plugging in there. Okay, sorry, I got a little glow going on up here. Let's take -4 and plug it in for A. Over, take -6 and plug it in for B. This is sometimes where I make my mistakes. Now I want you to look, before we go any further and simplify. A negative divided by a negative. Do the signs agree? Then our ending answer is going to be positive. Let's do a little note in our notes about this. The signs agree. Right? So it's going to be positive. Now think, what does a factor 4 and 6 share outside of 1? 2. So I can divide the numerator by 2 and I can divide the denominator by 2. And I'm going to get 2 over 3. Do 2 and 3 share a factor outside of 1? No, they don't. 1 is the only factor they share. There is the simplest form. And now you might ask yourself, Miss Clover, why didn't you say -4 divided by 2, which would give you a -2? Why didn't you say -6 divided by 2, which would give you a -3? Because again, when we have a negative divided by a negative, the quotient is going to be positive because these signs agree. You could do that, but then over here you're going to get -2 over -3. So then you need to recognize that I can simplify those negatives, and it would just be 2 over 3. Let's do the next example. You might be going, Miss Clover, I got this if this is what we're doing today. That's not too much. That's not too crazy. I'll just wait. All right, here's example 2, which what I want you to do is ignore the numbering on the front. So maybe scratch out the 2 that's there, and over the 3 that's there, put the 2. We're only going to do 2 problems on the front, okay? So we have m minus n over -12. And we need to evaluate this fraction when our variables are, so when m equals 3 and n equals -6. Now let's talk for a moment. Look over here at my expression. Am I going to have to use order of operations? Oh yeah, this fraction bar is a grouping symbol right now. Do you see why? Because I have more than one thing on top, right? So since this fraction is going to be a grouping symbol, I need to be very, very mindful. When the values I'm plugging in are negative, I need to be mindful that I bring in a parenthesis to isolate that negative, okay? It can start getting a little crazy if we have negatives going all over the place and we're not being mindful in isolating them. So go ahead and put a parenthesis around that -6 now, okay? Moving forward, let's make sure that we do that. So let's take our values and plug it in. 3 for m minus, see, -6. Isolate that negative. Thankful we put that parenthesis over here to isolate. Over -12. Now, since I have more than one thing going on the top here in my numerator, this fraction bar is a grouping symbol. So I need to take care of what's inside the grouping symbols first. That would be right here. 3, take away a -6. When you're taking away a negative, that turns into a positive. You take away the negative, it's gone. What's the default? Positive. So 3 plus 6 is 9 over -12. Now I have one number on the top, one number on the bottom, one number for my numerator, one number for my denominator. Before we move on, do our signs for my numerator and denominator agree? No, they don't. So let's make a really quick note here. The signs disagree. What does that mean? My final answer is going to be, it's going to have a negative in it, right? So what does a factor 9 and 12 share? They share 3. Divide by 3, divide by 3. 9 divided by 3 is 3. Negative 12 divided by 3, my signs don't agree. So it's going to be a negative 4. That's a negative sign right there. 3 and 4, the only factor that they share is 1. So I have 3 over a negative 4 as my simplified value when I evaluated problem number 2. Let's go to problem number 3. That's going to require you to go to the back of your notes now, and we'll write a 3 on the next side. Are you still thinking about why we, in math, so many times are focusing on simplest form? Here we go, number 3. We have negative 2y over x squared. And we're going to evaluate this. If you flip to the front of your notes again, the directions say evaluate each fraction for the given variable amounts. Express each answer in simplest form. Ms. Kluber has got to give you the variables. So if x equals 9 and y equals 3. So we're going to take our values and substitute them in to our problem over here. So we have negative 2 times 3. Do you know what I forgot to have you look at? Are any of these integers that we're going to be plugging in negative? No. If they were, remember, we would want to bring in our parenthesis to isolate that negative. So negative 2 times 3, I plugged 3 in there, divided by x is 9. So I'm going to take 9 and plug it in for x squared. Now, this fraction is representing a grouping symbol, right? Because we have multiplication going on top, exponents going on the bottom. It's not just a singular numerator and a singular denominator. So we need to take care of the top and the bottom before we can simplify the fraction to get the fraction in simplest form. There we go, Mrs. Kluber. Negative 2 times 3. Do my signs agree? Nope. So it's going to be a negative 6 over 9 squared. Now remember, exponents represent repeated multiplication. This means my base 9 is being used as a factor 2 times. So it really means 9 times 9, right? What's 9 times 9? 81. Now, I only have one value in the numerator, one value in the denominator. I'm good. My order of operations is complete. But now, do my signs agree for the numerator and denominator? No. So my final simplified version is going to have a negative in it, right? As my signs don't agree, my answer is going to be negative. What does a factor of 6 and 81 share? You might go, Ms. Kluber, I don't really know. Well, let's list the factors of 6. The factors of 6 are 1 and 6, 2 and 3. You might go, oh my goodness, the factors of 81, Ms. Kluber, I don't know. Well, let's use the factors of 6 to help us. We're not going to use 1 because 1's not going to change anything. If you take 81 and divide it by 1, you just get 81. Can you take 81 and divide it by 2? No, this is not an even number. It doesn't end with an even digit. Thank you, divisibility rules. How about 3? Because I know 3 is a factor 6 has. Well, remember the divisibility rule for 6. Add up the digits that make the number. 8 plus 1 is 9. Is 9 a multiple of 3? Then we have divisibility. So I can use 3. I can divide this by 3, divide this by 3, and I'm going to start making my way to the simplest form. Negative 6 divided by 3, the signs disagree, so my quotient is going to be a negative 2 over 81 divided by 3. Oh boy, this over. Well, I can break 81 up into 60 plus 21, right? And I can divide these values by 3 pretty easily. 60 divided by 3 is 20, plus 21 divided by 3 is 7. What's 20 plus 7? 27. Boom. 2 and 27? Well, look at this number right here. This is not an even number. 2 doesn't go into this. The only factors of 2 are 1 and 2. So this is in simplest form. Awesome. We have 2 more examples. Here we go. Example 4. You still thinking about why we simplify so much? All right, example 4. Negative 3x over y cubed. And we need to evaluate if we are told x equals a negative 4 and y equals a negative 2. Do you notice something about the values we're going to be plugging in? They have a negative. I want to bring in my parenthesis to help isolate that negative right away before I start substituting in. Now we are ready to plug in. So negative 3 times negative 4 over negative 2, I'm going to plug in for y using my parenthesis, negative 2, and I'm going to cube that. This fraction bar is being used as a grouping symbol because I have more than one value in the numerator, more than one value in the denominator. Blah, blah, blah. For some reason, that was hard for me to say. So let's go ahead and let's take care of order of operations. I'm going to go up here first. Negative 3 times negative 4. My signs agree, so it's going to be a positive 12. Negative 2 cubed. Now, this exponent is touching my parenthesis, right? So that means I take everything inside of there. So it's like negative 2 times negative 2 times negative 2. Negative 2 times negative 2, positive 4. 4 times a negative 2, negative 8. 8 and 12, do they share a factor outside of 1? You bet they do. So I got to think of that. They're both even. I could divide them by 2. But I know 2 times 4 gives me 12, and 2 times 3 gives me, or 4 times 3 gives me 12. So I can divide these by 4. 12 divided by 4 is 3. Negative 8 divided by 4, my signs disagree, so my answer is going to be a negative 2. 3 and 2, the only factor that they share is 1. So here's my simplified version. We have one more. Are you ready? We got this. Number 5. Gotta make sure I write it down correctly. Here we go. So our last one for evaluating, simplifying and evaluating fractions. I think I said that backwards, but that's okay. Here we go. C times the group negative 4 minus CD over D squared. And we need to evaluate if, write this with me, C equals 2 and D equals negative 8. That's a negative 8. Now, look at these values. Are any of them negative? Yes. So bring in that isolating parenthesis, okay? Here we go. Let's substitute in. Oh boy, here's where I tend to make mistakes. Negative 4 minus 2, plug 2 in for C, times negative 8, woo, over, that was a little crooked, Mrs. Kluver, negative 8 squared. Oh my goodness, this is a big one. Let's look up here. I got 2 parentheses going on. One is a grouping symbol though. One is isolating the negative. Do you see the difference? Okay. Also, this fraction bar is a grouping symbol. Here's a grouping symbol, and we have a grouping symbol inside of that. So we got to take care of what's on top, we got to take care of what's on bottom, and then we can start simplifying the fraction. So here we go. I'm going to focus on the top. I have grouping symbols up there, so I'm going to zone in. Inside my grouping symbols, I have subtraction and there's invisible multiplication. Which one am I going to start with? Got to use order of operations. The multiplication. M comes before S in order of operations. So 2 times a negative 8, that's going to give me a negative 16. So I'm going to rewrite this over here. I'm going to have 2 times a negative 4 minus 16 over negative 8 squared. Now, I'm going to go back on top. I still have that parenthesis, and this parenthesis is a grouping symbol. This parenthesis is, Mrs. Kluber, that should be a negative 16, right? 2 times negative 8 would give me a negative 16. There we go. This parenthesis right here is isolating this negative. So I'm going to focus back up here, go into my grouping symbol. I have a negative 4 minus a negative 16. Right away, I notice that double negative right there. And that double negative simplifies to be a positive, because when you take away the negative, what's the default? Positive. So -4 plus 16. Here's the negative team, they have 4 points. Here's the positive team, they have 16 points. Who won? The positive team did. By how much did they win? 12. So I'm going to come down here now, and I'm going to have 2 times 12. I simplified that up there. All over. Let's take care of this too. -8 squared. So that's -8 times negative. That got a little sloppy. -8 times -8. My signs agree, so it's going to be a positive 64. Okay? I still have this fraction bar that is a grouping symbol. I got to take care of the multiplication on top. What's 2 times 12? 24 over 64. Oh boy. What does a common factor 24 and 64 share? Well, they're both even, right? So I know 2 goes into them. Well, 3 doesn't go into them because 6 plus 4 is 10, and 10 is not a multiple of 3. What about 4? 4 goes into them. What about 5? They don't end with a 0 or a 5. What about 6? Well, it was only divisible by 2, not 3. And in order to be divisible by 6, it has to be divisible by both 2 and 3. 8. 8. Since it's divisible by 2 and 4, I can multiply those together. There's the GCF. So I'm going to divide by 8. Divide by 8. 24 divided by 8 is 3. 64 divided by 8 is 8. 3 and 8, the only factor 3 and 8 share is 1. All right, we did it. We simplified fractions by first evaluating and plugging values in. Oh my goodness, so much going on. Couple of things, go back to the front of your notes, okay? How do you use the order of operations? Well, first of all, you got to recognize when to use the order of operations. So underneath that question on the left in the front of your notes, I want you, let's create our checklist. We do our grouping symbols. Then what? Exponents. Then what? Multiplication or division, left to right. Then lastly, we look for addition or subtraction, left to right. The next question, why is it important for fractions to be in simplest form? Why? It is so much easier. If you think about, if you have 50 100ths, which is easier to look at or work with? Yeah, the simplest form of this fraction. Why? Because these numbers are easier to work with. We simplify fractions so that they are easier to work with. Write that underneath the question there. Why is it important for fractions to be in simplest form? It makes them easier to work with. All right, if you need to rewind the video and view parts, if you missed something or if I went over something too quickly, have a great rest of your day.